Hello students, today's first question is ABCDE is a 5-digit number. When multiplied by 13, it gives a number which is purely found by the digit 9. Then the value of ABCD, A plus B plus C plus D plus E is divisible by 8 equal to 27, divisible by 11 or all of these. So now the question says ABCDE is a 5-digit number. When multiplied by 13, gives a number which is purely found by the digit 9. So that means it will contain only digit 9. So 1, 2, 3, 4, 5. Now since this is a 5-digit number and this number is beyond 10, so that means this will yield us a 6-digit number. Fine. So that means it will yield me this number. Now in order to find the value of ABCD, I will shift this to this side. So this number will be basically equal to divided by 13. Fine. So basically what is this? This is basically the quotient of this division. So we will first divide 9, 9, 9, 9, 9 and 9. 6 nines and divide by 13. Right. Now 13 7 is 91. Remainder is 8. So 89. Now 13 6 is 78. So the remainder will be in this case 11 and carrying this 190. Now 13 9 is 117. So now remainder will be 2. So carrying 1 9. Right. Now 13 2 is 26. So here it will be 3 and 39, and 39 is 13 into 3. So remainder is 0. So basically this number is 76923. So the question says when 76923 is multiplied by 13, it yields us a number purely found by digit 9, and that number is 6-digit number. Right. Now the question asks what is the value of A plus B plus C. So this is basically 7 plus 6 plus 9 plus 2 plus 3. So this is 7, 6, 13, 13, 9, 22, 24 and 27. So the number is, their sum of the digits is 27. Now the correct option is equal to 27, right? But since there is given all of these also, we need to check other options also. Is it divisible by 8 or 11? No. So that means option B is the right answer. In any question which you find one of the options, if there is all of these, then if one is true, then you must try to have whether others are also true, so that the option might be A, D, but here only equal to 7. Option B is the right answer. The remainder when 75 raised to power 75 raised to power 75 is divided by 37 is. So the question is 75 raised to power 75 raised to power 75. When it is divided by 37, what is the remainder? Now, you know that 37 into 2 is equal to 74. Now here it is 75, so that means that when it is dividing this, so it will give me a remainder of plus 1 raised to power 75 raised to power 75. Now 1 raised to power any power, so that will yield me 1. So the right option for this will be, remainder will be 1. So right option will be option B. If you want a detailed video on remainder theorem, Fermat's theorem, I made a detailed video on that lecture, so you can watch it on my channel. Moving to next question. The unit digit of 1, 2, 3, 4, 5 k raised to power 72 is 6. The value of k is. So basically the question is 1, 2, 3, 4, 5 k raised to power 72. Unit digit is 6. We need to find the value of k. So basically question says that unit digit of this whole number k raised to power 72 is 6. Right? We need to find the value of k. Now options are 6, 8, 2, all of these. Now we know that 6, any multiple, any raised to power 6 at the value of k, so 6 has a cyclicity of 1. So 6 raised to power 1 is 6. 6 raised to power 2 is, again it has unit digit at 6. Any power of 6 has unit digit 6. So one option is A. Now we'll check whether the option is D, all of these, by checking for 8 and 2. Now for 2, we know that 2 raised to power 1 is equal to 2, 2 raised to power 2 is equal to 4, 2 raised to power 3 is equal to 8, and 2 raised to power 4 is equal to 16. Now this is the cyclicity and its pattern is 2, 4, 8, 6. So cyclicity is 2. Sorry, for cyclicity of 2 is 4 and the sequence is 2, 4, 8 and 6. Now since 72 is divisible by 4, right? So that means it's last after how many times? So that will be 1, 32, 18 times. The unit digit will be 6. So for 2 also, option C is also correct. So that means all of these is the right answer. Now for the sake of question, we'll check for 8 also. Now 8 raised to power 1 is 8. 8 raised to power 2 is 64. 8 raised to power 3 is 512. And 8 raised to power 4 is 4096. So 8426. So it is the cyclicity pattern, and cyclicity for 8 is 4. So you see again it is divisible, 72 is divisible by 4. So this will have 6 as its unit digit. So the right option for this is option D. If a b square whole raised to power 1 by 3 is equal to 125, where a is greater than b is greater than 1, and a comma b square belongs to natural numbers, then the correct relation is a is equal to b, a is equal to b raised to power 4, a raised to power 3 by 2 is equal to b raised to power 2 by 3, none of these. Now first option I can mark it wrong because it has been clearly given that a is greater than b is greater than 1. So a can't be equal to b, right? So a without solving also I can mark it wrong. Now since ab whole square is equal to 1 by 3, now 125 is basically 5 raised to power 3, right? So I can write this as 5 raised to power 3. Now here it is 1 by 3, so ab square will be equal to 5 raised to power 3. So we know that when we have power in fraction form, let us suppose this to be equal to this. So other sides, if I make cube both sides, so this will be equal to x is equal to b cube. So 1 by 3 into 3, 3 and 3 will get cancelled. So here 1 by 3 will get transferred over here, and it will be, or you can do this by cubing both sides. So here it will be 5 cube raised to power whole raised to power 3, and here 1 by 3 multiplied by 3 will be 1. So basically ab square is equal to, now another property is a raised to power m whole raised to power n is equal to a raised to power m multiplied by n. So 3 into 3 is 9. So basically ab square is equal to 5 raised to power 9. Now since a is greater than b is greater than 1, right? So let us consider some options. First option is, now first option is out of, let us consider the second option, a is equal to b raised to power 4, right? Now so I can write in place of a, I can write b4. So b4 into b2 is b6. So basically b6 is equal to 5 raised to power 9, right? So this basically means that I can write this b square whole raised to power 3, and here I can write 5 3 raised to power 3, right? Now if I make cube root of both sides, so I will be getting the value b square is equal to 5 cube, right? Or I can say that a is equal to, now if b square is equal to this, so a is equal to b raised to power 4, right? So b raised to power 4 will be equal to, if b square is 5 raised to power 3, so b4 will be equal to 5 raised to power 6, right? So now ab square is equal to 5 raised to power 9, and a is equal to b4 is equal to 5 raised to power 6. So I can write a equal to 5 raised to power 6 and b raised to power 4 is equal to 5 raised to power 6, right? So now the product ab square, so a is 5 raised to power 6, right, and b square is 5 raised to power 3. Now this is again equal to 5 raised to power 9, right? So this basically confirms this as well as a raised to power, a is equal to b raised to power 4 is equal to 5 raised to power 6, and our condition is being satisfied. ab square is equal to 5 raised to power 9 with option B, so we'll mark option B as the correct answer, right? If you want, we can check a raised to power 3 by 2 equal to b raised to power 2 by 3 also. Now here a raised to power 3 by 2, so this is basically a is equal to b raised to power 4, so I can write over here b raised to power 4 whole raised to power 3 by 2. So this is basically b raised to power 6, Now here it is b raised to power 6 and here it is b raised to power 2 by 3. So these are not equal. So option C is not the right answer. Option B is the right answer. If a 5-digit number M21N2, so here it is a 5-digit number M21N2 is divisible by 24. So we have been given that it is divisible by 24. Then the maximum number of possible combinations of M and N. So we need to find the maximum number of combinations of M and N. Now, it is divisible by 24, so that means 8 into 3 is equal to 24. So that means this number has to be divisible by 8 and 3. And we know that for the divisibility by 8, last 3 digits must be divisible by 8. And for the divisibility of 3, the sum of digits should be divisible by 3. So first of all, for 3, so that means 2, 2, 4, 5. So 5 plus M plus N, the sum should be divisible by 8. Right? So the first possible value I can have is 9. Right? Next will be 12. Next will be 15. Next will be 18. Right? So on. So that means if I shift 5 for each value, so M plus N in first case should be equal to 9 minus 5, 4. In second case 12 minus 5, 7. In third case 15 minus 5, 10. So basically this is an AP with a difference of 3. So 13, 16, 9, and 19 can't be possible because these are single digits. So 19 would be 10 plus, so up to 16. 10 plus 9, so M and N are single digits. Now for the value of N, now since last 3 digits has to be divisible by 8, in order that whole number has to be divisible by 8. So we'll find some values for. So first is, if I put the value of N equal to 1, so number will become 112. So divided by 8, so this is 8 ones are, and then 3 carry 32, so 14. So 14 into 8. Now the very next number will be, now for if I put 2, it won't be divisible by, so 122 is not divisible, 132 not divisible, then 142 no, and then 152 yes, it is divisible. So I will write 152 divided by 8, so this is 8 1 and then 7 minus 89, so 19. So that is, next will be with the 24, so that means next will be 1 5 and next will be 9. How 9, and so that will be 192 divided by 18, 8 2 16, then 32 24. So basically in the quotient we are having an increment of, just like here I told you about 4 7 10, and here it is 14 19 24. Right? So N can take this value and M plus N has to be this. Right? Now from here, when N is equal to, when N is equal to 1, possible values of M can be, so if N is taking the value 1, so possible value of will be 3, then will be 6, and then will be 9. I can't take further 13 because it will become 2-digit number, and both M and N are single digit numbers. Right? Now secondly, when N is 5, right? When N is 5, so first is discarded, second will be M is equal to 2. So from here M will be equal to 2. From here when N is 5, and from here 13 minus 5, 8. Now when N is 9, this can't be the value, this can't be, so here it is the value when M will be equal to 1 from starting from here. So next will be 4, and next will be 16 minus 9, 7. Right? So the possible combinations are, I can write also M comma N, 3 comma 1, 6 comma 1, 9 comma 6, 3 from here, 3 from here. So total 9 combinations are possible for this. So the right option will be option number B. If 11 raised to power A equal to 19 raised to power B is equal to 209 raised to power C. So I've told you, then the correct relation, so the relation is between A, B and C. So I've told you, whenever there is an equality between 3 or more numbers or 4 expressions, you must let it to be equal to something. So let us suppose this is equal to K. Let us say it is all, these are all equal to K. Right? Now, with this expression, I can say that 11 is equal to K raised to power 1 by A. Right? Now 19 will be equal to K raised to power 1 by B, and 209 will be equal to K raised to power 1 by C. Fine. Now if I factorize 209, since these are prime numbers, they can't be factorized further. Now 209, this is equal to 11 into 19. So I can write 11 into 19. 11 multiplied by 19 is equal to k raised to power 1 by c. Now since 11 is equal to k raised to power 1 by a, so I will write in place of 11 k raised to power 1 by a multiplied by, in place of 19 I will write k raised to power 1 by b is equal to k raised to power 1 by c. Now here the identity of exponents will be a raised to power m multiplied by a raised to power n. Now bases are same, powers get added, so this will be further equal to, this implies k raised to power 1 upon a plus 1 upon b, and on right side it will be k raised to power 1 by c. I told you in the previous video also that when bases are same in sign of equality, powers can be equated. So basically this means that 1 by a plus 1 by b is equal to 1 by c. So now this implies if I take LCM b plus a equal to 1 by c, or I can say by cross multiplying b plus a multiplied by c should be equal to ab. Now I will check the options. Now you see this third option, ab is equal, if I write it in this way, ab is equal to c multiplied by a plus b. Now a plus b or b plus a, both are same things. So this is the right option, is option number C. The remainder when 2 raised to power 54 minus 1 is divided by 9. So 2 raised to power 54 minus 1 is divided by 9. We need to find the remainder. I have told you that while we are finding the remainders, we must try to change the power in terms that it is somewhere near to the multiple of the divisor. So you know that 2 raised to power 6 is equal to 64 and 9 into 7 is equal to 63. So I can write 2 raised to power 54 as 2 raised to power 6 whole raised to power 9 minus 1 divided by 9. Right? Now this is 64, and when 9 will divide this, the remainder will be 1. So I can write this as 1 raised to power 9 minus 1 whole divided by 9. Now this will give me 0. So the remainder will be equal to 0. Right option for this question will be option number A. A natural number n is such that n is equal to a square is equal to b raised to power 4 is equal to c raised to power 8, where a, b, c are distinct positive integers. Then the least possible value of n is, options are 729,256, none of these. Now n is equal to a square equal to b raised to power 4 is equal to c raised to power 8. We need to find the least possible value of n. Now since n is equal to a square, right, is equal to b raised to power 4 and c raised to power 8. Now we know that these are distinct positive integers. So c will have the smallest value because c raised to power 8 is equal to n and b raised to power 4 is equal to n and a square is equal to n. So I can say that c is less than b is less than a. Right? Now to find the least possible, I can't have the value of c can't be equal to 1. Right? This is why, if it is 1 raised to power 8, so again this has to be 1 raised to power 8 and this can't be equal. So the next value for c will be 2. Now 2 raised to power 8. 2 raised to power 8 is equal to 256. Now I will see if it can be represented with some other integer raised to power 4. Now we know that 4 raised to power 4 this is from this 2 raised to power square and 4. So 4 raised to power 4 is also equal to 256. Right? Now for a square, so for that I have to write in a way that it should be a square. So this is basically 16 whole raised to power 2, or I can write this as 2 raised to power 4 whole raised to power 2. Now 2 raised to power 4 is 16, so I will write 16 whole square is also equal to 256. Now the value for c will be 2, value of b will be equal to 4, and value of a is equal to 16, and n is equal to 16 square, which is a square, is equal to b raised to power 4, so that is 4 raised to power 4. So the value of b is 4, a is 16, right? So this is b raised to power 4, and c raised to power 8 is basically 2 raised to power 8. So this is c raised to power 8, and the value of c is 2. So the least possible value of n is option C, 256. If PQR square is equal to ijk pqr. So that is equal to ijk pqr. So you see that the square of this any number, and these are the first three digits of a 6-digit number when it is squared, where I, j, k, p, q are all belong to real number, and p, q, r, and so this is a 3-digit number and its square yields us a 6-digit number. Fine, this has been given to us. Then the value, we need to find the value of I multiplied by j multiplied by k multiplied by p multiplied by q multiplied by r. Now options are 0, 720, can't say none of these. Now for square of any 3-digit number in which the 3-digit numbers are repeated in the square, so the only options for a square which repeat their digits are 0, 1, 5 and 6. Now let us suppose for 10 square, so this is 100. Since the square of a single 0 will yield us 2 zeros, so here the value after squaring, if r is 0, then it will yield 2 zeros, so 0 is not the option. Right? Now for 1, if I suppose the value of r equal to 1, then after squaring 1 square is equal to 1. So here r will also have this value, right? But we don't know the value of p and q. So for the 5 square will yield me 25, right? Now since this is 3-digit number, I need to have one more value over here. So if 5 square is yielding me 25, so if I suppose the value to be 625, right? Now since this is a 3-digit number, so 625 whole square, so this is basically equal to 390625. Now you see that last 3 digits are same as the PQR, so this is what is given to us, right? So how I found it, this is basically 5 square 25. So since this is a 3-digit number, I need to have a distinctive value for the third value of P also. So I checked for 625. So this is 390625. So this follows this principle. We need to find the value of product of all these digits. Since 0 is over here, so that means the product will be equal to 0. So the right option for this question will be option number A. The number of zeros at the end of 100 factorial is. So now this is a new category of question. We need to find number of zeros at the end of 100 factorial. We know that number of zeros can happen only when there are number of tens. We need to find then this is basically 2 into 5. So the minimum power which we'll be having out of this 2 into 5 will yield us the number of zeros, right? Let us suppose of any number, let us suppose a number n. It is basically equal to 2 raised to power 24 multiplied by 5 raised to power 20. So this means that it can have zeros equal to the minimum power which is of 5, right? Because 5 into 2 will yield me 10. Now over here, first of all we will find number of 5s. So 100, 5, 20. Again with 5 I will get 4. So number of 5s will be, number of 5s in 100 factorial will be equal to 20 plus 4, 24. Now we will check for 2s. Now 100, 2, 50, then 2, 25, and then 2, it will yield me 12, right? So basically number of 2s will be again 2, 6, and 2, 3, 2, 1. So since these are far more greater than 24, so minimum power is 5, or 5 is 24. So number of 10 it will yield us 24, but there is no option in this, so I will mark option D, none of these. This is the method to find how many zeros for a factorial given. The greatest power of 3 when 41 factorial is expressed in prime factors is. So we need to find how many 3's are there in 41 factorial. So how we'll find that? So we'll divide by 3, so it will be divisible by 13, right? 3 into 13, the lesser number than 39, then again with 3, so it will yield me 4 up to the point when it becomes less than the 3. So 3 ones are, so total number of 3's in will be 13 plus 4, 17 plus 1, 18. So the right option for this will be option B. The sum and difference of a number with its reciprocal are 113 by 56 and 15 by 56 respectively. The number is, so let us suppose the number is x and its reciprocal will be 1 by x. Now sum has been given of the number with its reciprocal is 113 by 56. So basically x plus 1 by x is equal to 1 by 13, 113 by 56, and difference is x minus 1 by x equal to 15 by 56. Now if I add this will get cancelled, so I would be left with twice of x equal to 56. Since denominator is common, so I will take it as LCM. So 113 plus 115, so that is basically equal to 128. Right? So this implies x will be equal to 128 by 56 into 2. So this is 264. Now both are multiple of 8, so this will be 8 by 7. Right? Now you see 8 by 7 is not in the option, so if I reverse this, so this is basically 1 by x is equal to 7 by 8. Right? So 7 by 8 is the right answer, option D, because the reciprocal of 7 by 8 is 8 by 7. Right? So if I add them, 8 by 7, so it doesn't matter, so you can consider this as the number, x is equal to 7 by 8, then 1 by x will be equal to 8 by 7. Right? So option D is the right answer. If p raised power r, p raised power minus 1 and p raised power s is equal to square root of p raised power 3 into 2 and p raised power 3 by 2, then and though two expressions have been given, then the value of, we need to find the value of r plus s whole raised power r plus s. So first we'll solve first expression, that is p raised power r, p raised power minus 1 and p raised power s. This has been given equal to pq whole raised power 2. Now since bases are same, powers can be added, so I will write p is equal to r plus s minus 1. Here this is square root, so this will be p raised power 3 by 2 whole raised power 2. So this gets cancelled. Now inequality, bases are same, so I can write r plus s minus 1 equal to 3, or I can write r plus s equal to 4. Now since the single expression is giving me the value of r plus s, so basically this is 4 raised power 4. Right? So this is basically equal to 256. None of the options is, so right option will be option D. You might be wondering, we didn't solve the second algebraic expression. You can solve this and you will check that again the value will be this. Right? Sometimes unnecessary values are also given, so that it might lure you to get some other option, but you can also solve this. We'll solve this for you also. So this is p raised power 3 by 2 into p raised power r equal to p raised power s dot p raised power minus 1 by 2. So here it will be 3 by 2 plus r, and on this side this will be s minus 1 by 2. So r minus s will be equal to minus 1 by 2 minus 3 by 2. So this is equal to 2 minus 4. So this is r minus s. So this will be equal to r minus s equal to minus 2. So r plus s is equal to 4. Now if you solve this, adding both, so you will get 2r is equal to 4 minus 2, 2. So this will give me r, the value of r equal to 1. Right? Now you can put the value of r in any of these equations. If I put in this 1 minus s is equal to minus 2, so minus 2 will be, minus s will be equal to minus 2 minus 1. So this is minus 3. So multiplying both sides by minus 1, so I will get the value of s equal to, so again r plus s is 4. Right? So basically we needed to find r plus s only. So this is giving us the individual values. So we need not to find the individual values. So right option is option D. If a and b are two perfect square digits and ab is a 2-digit perfect square number such that a into b plus a plus b is equal to ab, then the value of ba minus b minus plus a is options are 27, b square, 81, either of b and c. Now a and b are single digit numbers, are two perfect square digits. So we know that only 3 digits, 1, 4 and 9. 3 digits, these are perfect square digits. Now AB is a 2-digit perfect square number. Now with this combination, we can have only one 2-digit perfect square number, that is 49. So we can have value of A and B as 4 and 9. Now such that A into B plus A plus B. Now A into B is 36 plus 13. So this is equal to 49, right? Now we need to find the value of BA, so that is 36 minus B plus A. So B plus A is 13. So that is equal to 23, right? Now this is when I consider BA. Now AB is a 2-digit combined number. Now BA will be equal to, so this is when I taking it as product. So this is not right. BA. AB is this number. Now BA will be equal to 94 minus B plus A. So B plus A is basically 13. So this will be equal to 81. So the right option will be C. But option D is either of B and C. Now B, what is the value of B? B is 9 and B square will be equal to 81 also. So the right option will be option D, either of B and C. Here I assumed AB as product of A and B, but here it is given BA is by reversing the digits of AB. So that confusion led to be the wrong answer. In fact, it is the number obtained by reversing the digits of AB equal to BA. Sorry, not equal. So right option is option D. The least possible divisor of 25930800, by which we divide this number, we get the quotient as a perfect square. So we need to find the number out of 2, 3, 5, or the option D can't be determined, by which if we divide this number we will get a perfect square. So for this we will prime factorize it. So I can write this as 259308 into 100, and I know this is 25 into 4, or this is 10 square. So 10 square is 2 into 5 whole square. So 2 square into 5 square. So whatever I will have the prime factorization from this, I have to multiply it by 2 square into 5 square. Now 259308, 1, 2, 9, 6, 0 and 4. Fine. Now again with 2, 6, 4, 8, 0, 2. Again with 2, 3, 2, 4, 0, 1. Now 4, 3, 7, 7, 2, 9 and 1, 10. Sorry, this is 6, 5, 4. So again dividing by 2. So this will be 6, then 4, 16, 8, 2 and 7. Now 6, 4, 10, 18 and 9. So this will divisible by 3. So this will be 3, 2, then 1, 18, 6 and 0, 9. 2, 1, 6, 0, 9. So again dividing by 3, 7, 2, 0, 3. Now again dividing by 3, 3, 2, 4, 0, 1. 7. Now this will be 3, 30, 4 and 3. Again with 7, 7, 4, 28, 63, 49. Now this is 7 square, so 7 into 7. So this prime factorization yields me 2 square into this square, so 2 raised to power 4 into 3 times 3 into 5 square into 7 raised to power 4. So you see that this is square, this is also in pair, this is, but 3 has one more than one pair. So if I divide this whole by 3, 1 3 will get reduced and this will become a perfect square, because for perfect square every prime number should be in pairs. So 2 into 2, 2 into 2, 4 pair, 2 pairs from this, 3 into 3 into 3, 1 pair from this, 5 into 5, 1 pair from this, and 7 into 7 into 7 into 7. So 2 pairs from this, but this extra 3 has to be removed. So it has been asked with which number it must be divided. So that is 3. So the right option is option B. A soda water bottle is exactly filled with Coke, weighs 1600 gram, but when it is 1 by 3/3 filled, it weighs only 900 gram. The weight of the empty bottle is, so let us suppose the weight of empty bottle be W. So this is the weight of empty bottle. Now in the first case it has been given that the soda water is exactly filled with Coke, so it is completely filled and it weighs 1600 grams. So what does that mean? That means W plus weight of Coke. Weight of Coke is equal to 1600 grams. Right? Now in the second case it tells that when it is 1 by 3rd filled, it weighs only 900 grams. So that is basically again the weight of bottle will be there and 1 by 3rd the weight of Coke. So this is 900 grams. Now if I subtract this, so I will be getting this negative, negative and negative. So this will get cancelled. So I will be getting 1 minus 1 by 3 weight of Coke is equal to 700 grams, or this 1 by 3 is equal to 2 by 3 weight of Coke is equal to 700, or I can write weight of Coke is equal to 700 into 3 divided by 2. So this will be 350. Right? So this is equal to 1050 grams. So this is the total weight of Coke. Now the weight of Coke and weight of this is 1600 grams when it is completely filled. So actual weight of bottle will be 1600 minus 1050. So this is equal to 1100, then 5. So this will be 550 grams. So the right option for this question will be option number C. Thank you for today's lecture. Bye bye. Take care.